Now let us solve the third question of the exercise 5.1. The question is check the continuity for the given following or for the following functions. We are given four functions, and for each function we have to check the continuity, means we have to check whether the function is continuous or not. Now in this question it is not given that at this particular point check the continuity. Okay, we are not given any point. So what we will do in this case, we will take an arbitrary point. Arbitrary point means any point. Okay, so there is a word arbitrary. So I will solve the second part of the question, and the first one is for you for homework. So the second part of the question is, here the function is f of x is equals to 1 by x minus 5, and here one condition is given, x is not 5. Now why they have given this condition x is not 5? Because if f is equals to 5, then the function is said to be or the value you will get 1 by 0, which is infinite. So the function is not defined. So the function is not defined when the value of x is 5. That is why it is necessary to mention that here the x is not equal to 5. Okay, so we have to check the continuity, but we are not given any points. So we'll take let a be an arbitrary point. Arbitrary means it's of your choice, a random choice. Okay, so let a be an arbitrary point. Now at which point, now we will check the continuity at point A, and the procedure is same. We will find the left hand limit. So the left hand limit will be limit. Now we have done so many equations, so now we can directly write limit h tends to 0. At which point we have to find? At point A, its left hand limit, so a minus h. Okay, so the function is f a minus h. Now we are given function equals to f of x equals to 1 by x minus 5. Now f of x is given. Now we have to find f of a minus h. You will be surprised to know, but for most of the students this is the toughest part, to put the value. Okay, they make mistake here in putting value. So f of x is 1 by x minus 5. What about f of y? You just replace this x with this number. That's it. So limit h tends to 0 f x, this is x now. Okay, so f of x is 1 by x minus 5. So f of a minus h will be 1 by, means at the place of x, now we have to write a minus h. Okay, so 1 by a minus h minus 5. Okay, this is the most difficult line for the students, so be careful, don't make any mistake. So now we will simplify. We can put the limit. So when you put the limit, you will get 1 by a minus 0 minus 5, which is equals to 1 by a minus 5. Okay, here a is just an arbitrary number. Now we will find the right hand limit. Right hand limit is limit h tends to 0 f of a plus h. Okay, if you want, you can first write that line limit h at point a we have to find. So limit x tends to a plus f of x, then limit h tends to 0 f a plus h. Okay, if you want, you can also write this line. But if you practice, if you solve so many questions, then you will be able to write this line directly. So now here what we have to do next? We have to put the value of f of x. F of x. Here at the place of x we have a plus h. Okay, what is f of x? F of x is 1 by x minus 5. Okay, means we have to replace this x with this a plus h. That's it. So you'll get 1 by, now no need to write f because we are writing the value of this function. So 1 by x, x means a plus h here and minus 5. Now we can put the limit. We can put h equals to 0. So when you put h equals to 0, you will get 1 by a minus 5. See the LHS and LHL and RHL, not LHS. LH right hand limit, left hand limit. So LHL and RHL are equal. Now we only need to find the value of the function at point A. So we are given f of x is 1 upon x minus 5. So now what we have to find? We have to find the value of the function at point A, f of x. Can you relate? Means now at the place of x, we'll put a only. So you'll get 1 by a minus 5. So left hand limit is coming 1 by a minus 5. Right hand limit is coming 1 by a minus 5. And the value of the function at point A is also coming 1 by a minus 5. So you will write left hand limit is equals to right hand limit is equals to value of the function at point A. It means the function is continuous. F is continuous at A, and since this A is nothing but an arbitrary point, arbitrary number, so we will write f is a continuous function. Okay. Now see the third part of this question. F of x equals to x square minus 25 by x plus 5. This question is also for homework, but I'll explain this one. In this question, if you observe, you will find that the function is not in the simplest form or in standard form. We can simplify it, okay? We can write it in the simplest form. How? By using a formula. This x square minus 25 can be written as x square minus 5 square. Now we can use the identity a square minus b square, which is equals to a plus b, a minus b. And in the denominator we have x plus 5. So now we can cancel out this x plus 5 and x plus 5. So now the function becomes this x minus 5 only, which is nothing but the first part of the question. Okay. So whatever you will do in the first part, you just copy here and you will get your answer. So now let us see the last part of this question. Here the function is given f of x mod x minus 5. This is mod x minus 5, modulus function. Now what is this modulus function? So this mod is, let us define this mod. Mod of x means x is positive, okay, the function or the value is positive if all the x are greater than 0 or equals to 0, and you will get a negative value if x is less than 0. Okay, this is the definition of modulus function, which we have also discussed in class 11. But here we are not given x, we are given x minus 5. So what we have to do? We just replace this x with this x minus 5. Okay. So this x minus 5, this function x minus 5, mod x minus 5 can be defined as, just replace this x here, here as well as here. Okay, these are the conditions, very important. We cannot ignore these conditions. So we are going to replace this x with this x minus 5. So x minus 5, x minus of x minus 5. Here x is greater or equals to 0. Now at the place of x we have x minus 5. So x minus 5 is greater than or equals to 0. Here x is less than 0, not equal. X is less than 0. Here x means x minus 5. X minus 5 is less than 0. What do you have to do? We only need to replace this x with this x minus 5. 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 Okay. So now we will rewrite this function. This is positive if x is greater or equals to, when you transpose you will get x is greater or equals to 5. This minus 5 will become plus 5. And here minus of x minus 5. If you want, you can write it as it is, minus x minus 5, or you can also write, multiply here. When you multiply, you will get minus x plus 5. So plus 5 minus x, where this x is less than, when you transpose 5. Okay. So for all the values equal to 5 and greater than 5, the value of the function is x minus 5. And for all the values of x less than 5, the value of the function will be 5 minus x. Okay. So now we will check whether the function is continuous or not. But here we got a point 5. So we will check the continuity of this function at which point? At this point 5. Okay. So now we will check the continuity of the function at point 5. So I will write the function here once again. The function is, the value is x minus 5 for all x greater or equals to 5 and 5 minus x for all x less than 5. Okay. Yeah. So now we will find the left hand limit. Left hand limit means limit x tends to, at which point we have to find? At point 5 we have to find. Okay. So limit h tends to 0 f 5 minus h. Okay. Or if if you are confused that how to write, then you can write from the first line, limit x tends to, left hand limit hai, then x tends to 5 minus f of x. Now we will replace this x with 5 minus h. So we'll get limit h tends to 0 f 5 minus means 5 minus h. Okay, you can also start from here. Now see, left hand limit means all the values less than 5. Left hand limit means all the values, if you see on the number line, here is 5. So all the values on the left hand side means less than 5. So here the value of x is less than 5. So when the value of x is less than 5, the value of the function is 5 minus x. So in this case, we will take f of x equals to 5 minus x. Understood? I'll explain once again. We have to find left hand limit. So we will write limit x tends to 5 minus f of x, and then limit h tends to 0 f 5 minus h. 5 minus h means, from here also we can say 5 minus h. If you write from here, then from here also we can say that 5 minus h. 5 means 5, we are subtracting something from 5, means we will get a value less than 5. Okay. So here the value is less than 5. So where less than 5? See, the less than 5 condition is here. So here the x is less than 5. So when x is, so the question is saying whenever x is less than 5, put f of x equals to 5 minus x. And whenever x is greater or equals to 5, put f of x equals to x minus 5. Clear? So here 5 minus h. 5 minus h means less than 5. So for less than 5, the value of the function is how much? 5 minus x. X is less than 5. The value of the function is 5 minus x. So this is our value of the function at which point? At point x. But we have to write the value of the function at which point? At point 5 minus h. So be careful. As I said before, this is the toughest line for most of the students. F of x is 5 minus y. What about f5 minus h? Just replace this x with this 5 minus h. That's it. So limit h tends to 0 f. Now no need to write f because we are putting the value. So limit h tends to 0 5 minus x. X means 5 minus h. Again, so there are because of this minus sign, we'll put bracket Understood? F of x is 5 minus x. What about f of y? 5 minus y. What about f of 1? 5 minus 1. Similarly, what about f of 5 minus h? We'll just replace this x with this 5 minus. So we'll get 5 minus h. Understood? Now we will simplify. Limit h tends to 0. 5 minus 5 plus h. This 5 and 5 will cancel out. Now we'll put the limit. So here we are only left with the 0. So we will get 0. So the left hand limit is coming 0. Now we will find the right hand limit. Right hand limit means limit x tends to 5 plus greater than 5. Okay. So limit h tends to f 5 plus h greater than 5. Okay, so here x is greater than. Where is greater than condition? Greater than condition is here. So the question says that whenever x is greater than or equals to 5, put f of x equals to x minus 5. Means in this case, f of x will be x minus 5. But we have to put f 5 plus h. Means we just replace this x with 5 plus h. Okay. So we will get limit h tends to 0. What is the value of fx? X minus 5. Okay. X. Now x means 5 plus h minus 5. This 5 and 5 will cancel out. So we'll only left with h and we'll put the value of the limit, or we'll apply limit, we'll get 0. Right? Now we got the left hand limit 0, we got the right hand limit 0. Now we only need to find the value of the function at point 5. Okay. Now again see the question. The question says that whenever x is greater than 5, then put this value. Less than 5, then put this value. But when the function is also equals to 5, when the x is equals to 5, greater as well as equal. So when x is equals to 5, then also put f of x equals to x minus 5. Okay. You should know how to read it. Okay. So when x is equals to 5, in that case also value of the function is x minus 5. So in this case, see, now the x is 5. So f of x will be x minus 5 only. Right. Now we have to write f of 5, not f of x. So how will you write f of 5? Simply replace this x with 5. So we will get 5 minus 5. Okay, which is 0. So clearly the left hand limit is equals to the right hand limit is equals to the value of the function at point 5. It means f is continuous at x equals to 5. Okay.